Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Hello all, welcome to episode 9 of Fire Code Tech. On this episode of Fire Code Tech, I speak with Richard Meier, a fire and explosion investigator. Richard has formal education in mechanical engineering technology. Also, Richard is certified as a fire protection specialist and as a fire and explosion investigator. In the interview, we talk about the scientific method and how it applies to fire and explosion investigations. Richard explains fire effects and fire patterns and goes in detail on the human aspect of what it means to do a fire investigation. We speak about the differences between investigating a fire in contrast to an explosion when looking for origin and cause. Richard answers the question of what does it look like to be a subject matter expert in court for a fire and/or explosion investigation? Spoiler alert, it's not like Forensic Files or your favorite cop drama on TV. Don't forget to subscribe so you never miss an episode, and follow us on social media. Let's dive in. Well, hello, Richard. Welcome to the podcast.
Thank you.
So I wanted to get started with your background and how you got into fire protection.
Well, I'd like to make a little clarification, and I don't really work in fire protection. I kind of work around the periphery of it. I work in fire and explosion investigation. And the way that relates to fire protection is I'm sort of the Monday morning quarterback. I provide feedback as to what happened and what went wrong.
I think it's an important distinction, fire protection and fire investigation. They kind of go hand in hand as we try to model the codes off of what we see as mistakes and things that went wrong or could have been done better in fire. So interesting caveat there. I like that.
Okay, and now that I've said that, my background is I'm actually a mechanical engineer or a degree in mechanical engineering technology. And I spent about 24 years working in industry before I went into fire investigation. And the way I got into it was actually my wife, then my girlfriend. Her family been in fire investigation at this point for about 65 years. Her grandfather had actually started the first private fire investigation company in the world and was the first investigator outside of fire departments who actually specialized in fire investigation. She told me what they did for a living, which was way more interesting than manufacturing. So that's how I got into it.
Well, it sounds like you had a very technical background and a lot of experience with understanding how things work. And so that's important. So I'm sure you had plenty of groundwork for all that for your intro into fire and investigation.
As a fire investigator, you really have to know how things work, how they fail, what they're made out of, how they're made. And my background is great for that. From there, I had to learn, how to perform fire investigations. Since I did a lot of failure analysis and problem solving as an engineer, that kind of came naturally to me.
Very interesting. Yeah, the longer I'm in the fire and life safety industry, the more I realize that material science is a big part of what we do. So I like that point that you said about failure modes and understanding how things work. I think that's important. Yeah, the more I read about fire protection, the more I start to understand that material science and chemistry is part of what fire and life safety is about.
Yeah, and I spent about the first 10 years in my manufacturing career in plastics, one form or another. Plastics, thermoelastomers, things like that. And it's unfortunately a lot of the things that we use nowadays and use in our homes and our cars and everywhere else are petroleum-based materials, and they will burn.
That's a good note. It seems like increasingly we're getting into more and more plastics and everything that is made. Furniture, pretty much anything you could touch nowadays almost has some sort of plastic component, so it's a big deal.
It is.
So I understand, from my experience, the kind of work that you start doing as a fledgling individual in fire protection or a designer or somebody in the design side of things. But wanted to ask you, what kind of work do you start out doing as a forensic investigator? Yeah, what does that look like for somebody who's just getting into the industry?
Well, for a fire investigator, and that's all I do is fires and explosions, and things related to that. Well, first off, you have to learn how to do a fire investigation, which is learning what fire patterns are, how ignition occurs, how to conduct an investigation, following the scientific method, things like that. As my work as an expert, I also get involved in reading and interpreting fire codes and understanding what they mean. In a lot of cases where there's litigation, it's like, was the code being followed? Did it really have an impact on the case? Things of that matter. But as far as, how does one actually learn the ropes of becoming a fire investigator? Yeah, it's learning about conducting an investigation and the science behind it, the fire patterns, the chemistry, the fire dynamics, even things like building construction, building systems like the electrical system, the plumbing system, if it has, especially if it has fire protection, the fuel gas systems. A lot of cases I get involved with are propane or natural gas. Basically, you have to know a little bit about everything.
I could see how the role of a fire engineer in any capacity has to have knowledge about a wide range of things. So that's interesting that you talk about the plumbing systems and the electrical systems and some of the other components of the building, how that's important to understand that for the purpose of investigations. I really like what you talked about when you were speaking about the scientific method and, starting to understand fire patterns and some of the different baseline fundamentals of fire investigations and explosions investigations. I was wondering if you could speak a little bit more about your approach as a forensic investigator and maybe, touch a little bit more on what the scientific method is for fire and explosions investigations. And yeah, if you could go a little bit more in depth on that.
Well, the scientific method, really goes back a couple hundred years, and it's just a way of collecting, analyzing, and interpreting data. In fire investigation, we basically use 6 or 7 steps. The full scientific method, it has a couple more steps because it involves peer review and feedback. And in my line of work, my peer review and feedback is, did the jury like it and did they agree with me? But the scientific method is, basically it's acknowledge the problem. There was a fire. Define the problem. Well, we have to figure out what started the fire so we can prevent it from happening again. Collect data, and that's everything from witness interviews to the observations we make at the fire scene. May collect physical evidence that we believe was related to how the fire was ignited or the first fuels involved. And then we take that evidence and our observations, we start developing hypotheses. Hopefully you can come up with more than one. The next step, after we develop the different hypotheses about the ignition scenario or the fuels in the ignition sources, the right way to do it is actually try to disprove it. You try to disprove each hypothesis. And when you're left with only one that you can't disprove, hopefully, that is the most likely cause of the fire. Now, in some cases, it's a fairly simple thing. I've had cases where we've had video surveillance cameras that actually captured the fire igniting. On the other hand, there are cases where there were no cameras, no witnesses, or the witnesses weren't necessarily completely reliable. And it's not that they're bad people or mentally deficient or anything. It's just that your behavior during a fire changes. It's a very traumatic event, even if you're not directly involved with the fire. It's a traumatic event, and it alters your perception of reality. There are cases where somebody says there was fire coming out every window, when in fact the fire was only coming out one window of the structure. And what it really means is there was fire coming out every window that I looked at. So when dealing with witnesses, you have to confirm that information with physical evidence, if at all possible, and not just take any particular piece of information as gospel. And as I said before, we're trying to disprove our hypotheses, not prove them. And the reason is if you're trying to prove it, you get into what's called bias, especially expectation bias and confirmation bias. If you go into an investigation and you think that you already know the answer, that's expectation bias. And then you start disregarding any evidence that tends to disprove your preconceived answer and only pay attention to the evidence that corroborates it, which of course leads to bad results. The general picture, there is no good feedback to help us prevent the incident from happening again. Smaller scale, I've been involved in several criminal cases where fire investigators have gone in and, this has to be an arson, and completely ignored any evidence to the contrary. In the cases I've been involved in so far, I've managed to keep innocent people out of jail. There are many documented cases where people have been put in jail and at least one has been executed based on very bad fire investigations. So it is imperative that we follow the scientific method, even if we don't like the result.
That's really interesting to hear you talk about the human aspect of fire and investigation. Usually, when I think of fire science and fire or an explosion investigation, I think of the science of it or the technical aspect in which you are looking at the physical evidence, you're looking at the fire patterns, and that sort of thing. But I didn't think about the fact that there's a human component of it. Could be video. There's other avenues in which you could learn about this investigation or this fire event. I liked hearing about that. That's really interesting.
And that human element also plays into both fire investigations and fire protection. How do people react during a fire, especially if they are intimately involved in the fire? Do they run for the closest exit? Do they run for the exit that they came in from? And that's often the case, especially in venues that they're not that familiar with, bars, restaurants, theaters, things like that. And that's why we have a history of horrific events. The club in Rhode Island,
Station nightclub.
Station nightclub a couple of years ago. The Coconut Grove nightclub in Boston in the 1940s. Kentucky Supper Club in the 1970s. The Iroquois Theater in the 1906 in Chicago, where you had 600 dead. And it's not just the people who are involved directly at the fire at the time. It's what about the people running the place? What do they do for training? What did they do for fire prevention, protection? What did they do that actually made the situation worse? Did they lock exits so people wouldn't sneak in without paying a cover charge? Some things like that. So, things that I look at are also things that protection engineers look at.
I think that another great point you touched on is investigating with a solid background in science and with good scientific approach. I was reading the Q1 issue of the SFP magazine in 2019 was all about fire and investigation. And I was reading about how since there's such a variety of people involved with fire and investigations that there's a wide set of gradient of quality science that's being done. Some people are performing great fire science and some people are using more qualitative or less strong scientific method approach. So I thought that was a great point you touched on how important it is to check your bias and be sure to use solid science and not just colloquial or trying to confirm your own bias.
Yeah, as we refer to it as old wives' tales and on-the-job training from the guy who fell off the fire truck. Now, there's actually two documents that are, if you're going to be in fire investigation, that you have to learn, and that is the first is NFPA 1033, which is the standard for qualification for professional fire investigation, the standard for professional qualification for fire investigation, and that'll tell you what it is that you need to be able to do and the topics that you need to have knowledge of, and it's the minimum. It's not the end all be all, but it's the minimum. And there are some arguments in the industry because the document only specifies that a fire investigator need to have a high school education, high school diploma or GED, and then some knowledge beyond the high school level on the various topics. When in reality, a lot of the cases that I get involved in, you need to have a really strong understanding of some engineering principles, thermodynamics, chemistry, fluid dynamics, material sciences, things like that. And but anyway, that being said, the next document that anybody involved in fire investigation should have is NFPA 921, and that is the Guide for Fire and Explosion Investigation. And let me clear up a little something first. People say, I don't have to use it, it's only a guide. Well, the reason it's a guide is in NFPA speak, a standard has mandatory language in it, and a guide has recommended language in it. NFPA 921 has 30 chapters that deal with all different kinds of fires and explosions, everything from residential fires to fires in farm equipment. And you can't say, thou shalt perform a farm equipment inspection if you're doing a residential fire. So that's why it's a guide. If you look at NFPA 1033, it refers you to NFPA 921 on how to do things. And both of these documents are really the only peer-reviewed, consensus-built documents on fire investigation. There's lots of books out there, some of them good, some of them not so good. These are the only two that have been, basically vetted by the industry.
Very interesting. In preparation for interviews and just out of pure curiosity, I've taken a look at 921 before, and it has a lot of great information, and it's really interesting to read. I've never been involved with a fire investigation or an explosions investigation myself, but the document seems very robust, and I think it's definitely good to be based in science and have a background or something to back you up. There's not too many cases where leaning on peer-reviewed science has done people a huge disservice. So I think that's an important point that you made there. Yeah, I wanted to talk about approaches in 921 or, some of the factors in 921. So I was reading through 921 and I saw that there are several different fire patterns or just basically things to look for in different types of fires, like apartment fires. And, I was doing some reading on different types of fires like point source fires or area source fires. Didn't know if you had some more detail about those or kind of what those are and, factors you're looking at. I liked hearing you talk about windows, and seeing how many of those are exploded or the physical patterns involving with those windows. Just wanted to hear a little bit more about that.
Okay, well, I can't talk about fire patterns without first talking about fire effects. And a fire effect is the effect that the fire has on a particular material. It may be melting, it may be charring, it may be loss of mass, it may be change in color, it may be change in chemistry. An example of change in chemistry is gypsum wallboard. Gypsum will go through a process called calcination, and what it is the heat drives the water out of the gypsum. So you have chemically bound water, and then you also have free-floating water that's in this mixture. The heat drives it out, and it turns a solid, hard material that normally you'd have to punch pretty hard to put a hole in it, into the soft chalky stuff that crumbles when you poke it with a finger. If we look at that just as an example, so that's a fire effect. Now, if we look at it on a wall and we see that it starts in the lower left-hand corner of the room and extends upward and to the upper right-hand corner of the room, well, that's a fire pattern. And the patterns can be a large effect or collection of effects. Actually, fire patterns can actually be very small, too. I've had cases where we're looking at, say, a gas leak out of a butane lighter. And in that case, you're looking at fire patterns that might only be a couple of millimeters. But generally speaking, when we're talking about fire patterns and say, a residential fire, we're talking, fairly large patterns. Could be a couple of feet, could be, size of the room, whatever. But we look at those patterns, and there have been a lot of things attributed to fire patterns over the years as this shape means this and this shape means that. And some of that is true, some of that's not so true. But say if you have a what we call the classic V pattern, you have a pattern that starts small at floor level and goes upward. Well, we can infer from that, hey, there's a fire that started there, that the fire plume went upward. Once it hit the ceiling, basically it hits resistance, so it starts going sideways, and that's why your plume goes from basically an inverted V or a straight up and down pattern to going wider at the top. So we can say, okay, a fire started here or was burning here. The more important thing I think about fire patterns is they can tell you time and or intensity and also direction. And that's the goal of fire patterns really is to find the origin of the fire. Where did the fire start? So if we look at each pattern and we say, okay, this burned either burned very hot or burned for a long time, and also it can point us in a direction. Well, we know which way the smoke went, or the fire plume went. So if we go the other direction, well, the fire pattern's in that way. And if we take more than one of those, we take two or more fire patterns, we're starting to do what we call heat and flame vector analysis. So we take all those fire patterns, and it will, going back from whence they came, that will point us to the area of origin. And the area of origin is important because if we can't determine the area of origin, we're going to have a hard time determining how the fire started. Once we get that origin down to as small an area as possible, we can start looking for the potential sources of ignition and the potential first fuels and additional fuel packages that added into the fire.
The term I've heard over and over again for fire and investigations is origin and cause. I believe that's a term I keep hearing.
It is, and people used to say cause and origin. Let's find out what caused it, and then we'll know where it started. And it's like, no, that took fire investigators a long time, but they finally figured out they were doing it backwards, and you're just randomly attributing the cause of a fire to something, and therefore that's where it must have started. And one of the things to keep in mind that one of those lessons we learned the hard way was the greatest area of damage is not always where the fire started. It just happened. It may be where the biggest fuel package was, or it may be the room that had the best ventilation. So that's why we do all this analysis to try to figure out where it started, figure out how it started. And another common misconception is cause. And according to NFPA 921, the definition of cause is the person or entities that brought together the fuel and the ignition source to bring about the fire. Now, people will say, well, in a very simplistic way, they'll say, okay, well, we tracked the fire to the kitchen. We tracked it to the kitchen counter. What do we got? We got a coffee maker and a toaster. The toaster was unplugged. Therefore, the coffee maker caused the fire. Well, the coffee maker may have been the ignition source of the fire. The coffee maker may have provided the first fuels for the fire. But why did the coffee maker decide to start a fire? No, the coffee maker is not really the cause. The cause is, what made those happen? Was it the coffee maker was dropped and something was broken inside that allowed a hot wire to come in contact with a flammable piece of plastic? Did the coffee maker have a failed temperature cutout that allowed it to get too hot? In which case, the first cause would be an accidental dropping of the coffee maker. The second cause could be a design or manufacturing defect. It's one of those things where you have to keep asking questions. Kind of use the Socratic method till you run out of questions to ask.
Very interesting. I like hearing about that. It's very fascinating to hear you talk about different failure modes, or you're really a detective, trying to understand the cause of these fires. And as somebody who works in the design side of things, I'm used to solving problems of a different variety. But yeah, it's really interesting to hear you talk about that.
And one of the areas I do work in is analyzing fire protection systems. Did they work, or generally when I get there, they for some reason they were not effective. So it's a question of were they completely out of order? Was there some other factor such as the occupancy had changed but the fire protection hadn't? Was there something that kept them from working properly? Once in a while you run into a case where somebody deliberately disables the fire protection system so that when they start the fire it burns better.
That's scary stuff. Yeah, I always wonder about, in these cases, about fire protection systems and, their impact on all of it. But yeah, that's a great point. That's a component of the investigation as well, as what role did the fire protection systems play in the fire. So another thing that I wanted to talk to you about is what are the differences in investigating an explosion as compared to a fire? Is it the same type of approach, origin and cause approach, and looking for the same things, or what kind of how do they contrast?
Well, generally the approach is the same, although you may have to look for different things. As I do a lot of gas explosions, and some of them are small. It's the gas grill exploded, and well, we pretty much know where that happened. But some of them are, say, a household explosion, where in some cases, you may have a couple of broken windows and a shifted wall or two. But I've had cases where the house has literally been turned into toothpicks. Yeah, that's what we call a high order explosion for obvious reasons. But in such cases, that the residential type explosions or the large industrial gas explosions, or it could even be a dust explosion for that matter. It's any diffuse fuel. You don't have an origin per se, as basically the epicenter of the explosion. Well, I use epicenter loosely because it typically refers to an explosive as opposed to a diffuse fuel explosion like leaking gas or dust or something like that. But that being said, it doesn't matter so much as where the fuel was ignited, because let's face it, most of our houses and businesses and whatever else are just a long list of ignition sources from one end to the other, with automatic things that turn on and off, creating small arcs, pilot lights and water heaters, things like that. So the more important question is, where did the fuel come from, and why is it in a place where it's not supposed to be? So in cases like that, we're actually the most important question is, where's the gas leak?
Definitely. I'd like to hear about a case that you thought was exceptionally interesting or maybe challenging. Yeah, I didn't know if you have a specific example of one of those cases that you're involved in.
Well, actually, I've had two cases, and I can talk about them because they're both closed. Generally, I don't discuss cases that are open and in litigation. But the first case was in Detroit, Michigan. It was a gas leak, and this was a catastrophic explosion. The homeowner was entering through the back door, turned the light switch on. Basically, the house turned into smithereens. There was a debris field extending about 100 yards or more in every direction. The house next door literally had shrapnel that went through the exterior walls, through interior walls. And this was a house that was built in the 20s, so it had lath and plaster. I mean, this is stuff that'll normally stop bullets sometimes. But they had shrapnel that had gone through multiple walls. Unfortunately, nobody got hurt in that one. The homeowner at the house had exploded, unfortunately, died from his injuries. But in this case, we had a home that was initially hooked to natural gas and then was later converted to propane because the owner of the property owned a propane company, so he could get propane fairly cheap. But the gas line still ran into the house. So then the question became, where was the leak? Not so much as, what the ignition source was. More or less likely that it was the, turning on the light switch is what did it. But it came down to doing an evaluation of both systems, and we had found out that the natural gas coming from the gas company, they had a number of leaks in a gas main across the street, and this is about 60, 70 feet away. The gas main was an old steel main that was almost 80 years old. It had a lot of time to collect corrosion, had a history of being repaired every 10 years or so. And on the couple of days before the explosion, there were some heavy rains. What that does is it actually seals the ground. Normally, the gas was basically coming out of the pipes and going through the sandy soil straight up, and then you could tell there was a line of dead grass that followed the gas main. But on the couple of days before the explosion, there were some couple of days of heavy rain, and what that does is it saturates the top of the soil with water, making it kind of impervious to the gas flow. So the gas decided, personifying the gas, which I shouldn't do. But the gas then went laterally under the roadway, under the front lawn, and leaked in through the old basement walls that were pretty porous block. By comparison, we found no issues with the piping for the propane. That is only a couple of years old. It was plastic. It was all solid. No issues found. So we determined that it was a gas leak from the gas main is what led to the explosion.
It's really riveting. I mean, if the guy was selling propane, I would have guessed, first of all, that was the reason. But it's interesting how, the investigation of the utilities and some of those factors is what led to a result there.
Okay. Now, the second case I want to talk about is a couple of years ago, we had Hurricane Irma come through Florida, and it came across the southwest corner of the state towards the northeast portion of the state. And I had a case in Fort Myers that had a minor propane explosion, but unfortunately a fatality related with it. And what happened in this case was there was a propane leak during the hurricane. There was a hurricane leak within the home. The occupants of the home could smell something, but they weren't sure what it was. And a couple hours later, there was an explosion. Well, to backtrack a little bit, prior to the explosion, the home was equipped with fire sprinklers. A sprinkler head in the laundry room broke, and it was sometime after that they started smelling something. Well, what happened was during the storm, a power line, there were some high voltage power lines that were very close to the home. A power line had snapped, fallen onto the ground, and come in contact with the riser for the water for the fire suppression system, for the fire sprinkler system. And that had actually knocked out the one sprinkler head. And you're thinking, how can that happen? Well, strange things happen when lightning strikes. And especially when you consider, the piping inside the house was actually PVC. But I did some resistance readings on the piping, and it turns out that even with plastic piping and what you normally consider, non-conductive materials, it did conduct some electricity. It was between the metal riser on the outside and where the where the sprinkler head was on the inside was about 200 ohms, which normally isn't going to conduct a lot of current. But when you have a 12,000 volt line come down and it goes where it wants to go. But at the same time, that it knocked out the sprinkler, the power from that power line actually went through the natural gas, or excuse me, not the natural gas, the propane piping, which came in about close to the sprinkler riser, and they're bonded together and grounded. So the energy also made its way through the propane piping within the house towards the dryer in the laundry room, and had burned a series of small, almost microscopic holes into the stainless steel flexible connector between the house piping and the dryer. So that provided the path for the propane to get into the house. So as I said, sometime between when the power line, or about 2 hours after the power line came down, the explosion occurred. And what I observed was that at the back of the house there was a bedroom, and the door to the bedroom was not damaged. However, the screen on the screen porch behind the bedroom was melted and burned, which led me to the conclusion that the back door was open. Well, the occupant of the bedroom down there was also known to be a smoker. In fact, we found ashtrays and cigarette butts and everything else. So unfortunately, I think what happened was that he had opened the door, went to light up a cigarette, and then basically ignited the gas, and then all the pressure that would have been created by the expanding burning gases, which normally would have broken windows and things, basically went out the back door where he was standing. He died from his injuries. A couple of different scenarios and but unfortunately same outcome, I guess.
Wow, those are really interesting cases. And yeah, it's really cool to hear about those different cases and just kind of the different factors that you're looking for. Another thing that I wanted to talk to you about is what are the most common fires that you are investigating? It seems like you had some couple stories from residential fires. Is that the more common type of fire or type of investigation for you?
Well, it is. Residential fires are the most common type of fire. It's not all that I do. I do basically a little bit of everything. I do residential fires, industrial fires, commercial buildings. I've done fires on large yachts, personal watercraft, vehicles, everything from, passenger cars to large heavy trucks, garbage trucks. Always fun doing a garbage truck, as you can imagine. They smell lovely when you get there. But yeah, I do a little bit of everything. But as far as the number of fires, the most common fires in the U.S. are residential fires, and of those, almost half of them are cooking fires. From there, you get into appliances, electrical issues, less common things, candles, kids playing with matches. You even get into things like spontaneous combustion, where somebody's been staining something and they took all their rags and threw it in a trash can in their workroom or laundry room, whatever. And there are certain oils that will self-oxidize, and when there's a lot of it in one place, they self-oxidize real fast to get real hot.
That's wild. Yeah, I guess I didn't know that about residential fires being the number one case, but that makes sense. Seems like even more of a reason to ask people to put fire sprinklers in their house, but I don't see that happening anytime soon.
I am an advocate. I freely admit I don't have them in my own house, but I do have lots of smoke alarms. I'm a big advocate of making sure that you have the proper number of working smoke alarms in your house. I've only had, out of the hundreds of fires and explosions I've investigated, I've only had one case where there was a working smoke alarm in the house and a fatality, but that wasn't it had really had nothing to do with the smoke alarm. It was a different, it was a daytime fire in a kitchen that got out of hand. So the smoke alarm really didn't play into it. But other than that, yeah, it's, a lot of fires occur at night. You only got about 3 minutes warning from the time the smoke alarm goes off to the time that the fire becomes untenable in the room, where it occurs, if not the whole house. So yeah, it's $10 well spent. If you can only afford one smoke alarm, hell, you can get a smoke alarm at Walmart with a battery for $4.
Good plug for fire safety systems. People need to probably be testing their fire alarms and whatnot too.
Not just have the smoke alarms, but do the maintenance on them. It's do the test every so often. Ideally, people would test them for smoke. There is cans of artificial smoke you can buy. Really, that's used more by professionals, but wouldn't hurt to do it at home. And also, make sure they're not past their prime. Smoke alarms are supposed to be replaced from 10 years from the date of manufacture. And the reason is that as they get older, they become less reliable. They get coated with dust. You may have some issues with humidity and corrosion and delamination in the sensing chambers. There are a lot of things that can go wrong with them. So if they're more than 10 years old, time to put a new one in.
My grandpa was a fireman and a fire chief, so I always remember growing up, he would have a box of smoke detectors around for such occasions. So I wanted to move into some professional development topic because it seems like that you have had a very successful career so far in fire investigation and forensics. And so I wanted to pick your brain a little bit on things that you would suggest for others in the industry. What do you recommend as a good place to go to learn about fire and explosions investigations?
Well, there are a lot of good resources out there, and it kind of depends on what career track you're following. If you are in the fire industry, as in, and I say, fire department, fire rescue, things like that, there are a lot of resources available to the public sector through the state fire colleges. Things like that. In addition to that, whether you're public or private, there are a couple of associations that deal with fire investigation directly. There is International Association of Arson Investigators that they provide training both in person and online, especially nowadays with the coronavirus pandemic. They've started doing some online training. There is the National Association of Fire Investigators that also does training. There is a program called cfitrainer.net, which is online, which is free training for fire investigators. It's a collaboration through the International Association of Fire Investigators, receive some financing through the federal government. There are, basically you can sign on and take a lot of different lessons for free, everything from, figuring out ignition sources to some fire chemistry, everything else. There's probably about 70, 80 different couple-hour programs on there that you can take. And those you can test for credit, which is sometimes necessary for, depending on the certifications you can get. Some of them require you to have a tested training, especially IAAI puts out or provides the CFI or Certified Fire Investigator certification. NFPA does the Certified Fire and Explosion Investigator certification, and then there's other ones besides that. And then beyond that, there are magazines on fire investigation put out by the different associations. There are also more periphery type associations that deal with fire protection and also to some extent fire investigation. There's the International Association of Fire Safety Science. There's ASTM does standards on fire protection and forensic investigations. The list is endless. NIST, the National Institute of Standards and Technology, has a lot of information online. They do a lot of fire testing. One of their most famous ones is the Christmas tree videos that they put out. They start sending out the information on every December or November, and it's how fast a dried out Christmas tree can bring your fire to basically to flash over in full room involvement, which can be as little as 30 seconds. We no longer have a live Christmas tree in the house, needless to say. But there are lots of places to go that you can look for information on fire investigation.
That's great. I appreciate all the references and all the good spots. I try to promote people to be knowledgeable and seek these resources and stay up to date on what's going on in the field. But speaking about what's going on in the field, what do you see any meaningful trends right now in the industry? I mean, you don't have to go into what the coronavirus is doing, but but you can. But also, just what do you see as meaningful trends in the industry right now?
Well, I'm going to go back a little bit because in fire investigation, there really was no science involved until the late 70s, early 80s. You had some people that were doing basically using a scientific method in investigation. A lot of it was old wives' tales and just passed down bad information. So from there to the present day, the amount of research and information available, the material sciences and the dynamics and everything of fires has really gotten so much better. But there's still a lot of room for improvement. And once in a while I see a little backsliding. It's there are people who want to learn everything they can and do a good job, and there's a few people still out there, unfortunately, who just want to kind of coast along. But overall, I see the trend is that more science, more education is being expected of people who are testifying as experts in fire cases. And it's for every step backwards, there's 3 steps forward. So basically it's if you're going to be hired, at least on the private side as a fire expert, you're going to need an engineering or a chemistry degree. There's even a college or two that does degrees in fire investigation now. Eastern Kentucky University, I know for a fact, does bachelor's program in fire investigation as part of their fire protection program. I think Worcester Polytechnical Institute may do a fire investigation degree, or at least an emphasis on it in their fire protection program. I haven't looked into that lately. If you're going to be, an expert on the private side, it's education is really the way to go. Education, training, and of course experience. And experience is the hardest thing to get. And to be honest, fire investigation is a fairly hard field to break into. There's a lot of large companies hiring, investigators on a part-time basis, but to be able to do it full-time, that's kind of hard to get into.
Yeah, I think it's interesting. I didn't, coming out of college with a degree in fire protection and safety technology, I didn't really see a lot of opportunity in fire and investigations. I don't even know if that crossed my mind at the time. But yeah, it seems like a very interesting field and something that I always find fascinating. So I appreciate your insight. Yeah, I wanted to ask about, this is kind of a professional development topic, but I see from looking at your LinkedIn that you had some experience in being on the NFPA 921 committee. I didn't know if you would tell me a little bit about that, and talk about, is it meaningful to get involved with these processes of codes and standards?
Okay, actually, I've never been on the 921 committee. I've been going to meetings for about 10 years now. I've been a member of several task groups on 921. And the thing is, there's about 10,000 fire investigators in the U.S. and 30 spots on the committee, and everybody wants to be on it. So, but not everybody can be. I've been involved as I can in the standard making process for that. I have been an alternate member of the NFPA 1033 committee, and I am currently a member of the NFPA 901 committee. And 901 is the standard for reporting. It was reporting fire incidents. Now it's just reporting incidents for first responders. That's not the official name, but it's basically becoming a little broader as we go. But basically, anything that the fire department will show up to, it's how to record that data and get useful data and statistics that can be put into the code making process. The feedback on whether things are working or not. So I guess we're kind of getting back to where we started with this interview. On the 901 committee, and so we try to make sure that it's good and useful information that can actually be put to use, and not just recording, not just checking boxes to make sure the boxes are checked.
That's awesome. Well, I just wanted to end with one more question. I think I'd be kicking myself in the pants. I know this is kind of jump around in the interview selection here, but yeah, I just wanted to ask you about expert witness testimony and kind of to hear from you what that looks like, because I think I, like most people, have this law TV show image in my mind when I hear a subject matter expert testifying on a criminal case or on a different case. But yeah, I didn't know if you would speak about what that looks like a little bit for my interests.
Well, most of my testimony is actually done in depositions. Very little of it is actually done in the courtroom. And working on the private side, I get involved in a lot of litigation cases, and typically judges like the parties to settle that on their own. either through mediation or through agreement, some other form of agreement, without making the judge, go through a 2-week trial. Judges have big calendars and lots of things, and if everything went to trial, basically our legal system would grind to a halt. So most of my testimony is done in depositions, which can last a couple hours. It can last all day. I've seen, not me personally, but I've seen other depositions that have gone for several days. And think of it as preparing for an oral exam with a professor who doesn't like any answer that you give them, because the deposition is typically taken by opposing counsel. So you're going to have to be ready to defend your answer, justify your qualifications, everything else. And yeah, it sounds bad. It's really not that bad. But it's I consider it the most stressful and difficult part of the job. Now, compared to that trial testimony, I would much rather prefer to testify in open court, because the reality is that the opposing counsel can only flog you for so long in public before the jury starts to feel sorry for you, and will go with you just because they don't like the other guy. So, and it's an 8-hour deposition may end up being a 15 minutes in the courtroom. So it's less stress, less headaches. Oh yeah, So as far as testifying goes, it's generally depositions, and once in a while you get to go to court.
That's interesting. I didn't know about that, but that's very fascinating to hear you talk about that. So just I know I said that was the last question, but just had one more thought come about that we didn't get to earlier. Speaking of laboratories and analysis and good science, I've seen some images on your website of you doing laboratory work, but I didn't know what kind of things that you would be able to investigate in your laboratory that you wouldn't be able to do in the field or just through investigation.
Okay, well, I have a fairly small laboratory. It's how many square feet? Probably about 15 by about 20 feet, roughly. So you can do the math. But it's pretty well packed with all kinds of different stuff. And in my case, I am primarily concerned with ignition sources and first fuels. How did the fire start? Is this whatever capable of igniting? Is ignition source A capable of igniting first fuel B? So my experiments or tests are generally on a pretty small scale. Now, you may get some people or entities that have huge labs. If you ever get a chance to go to the NIST lab or the UL lab, these things are basically the size of a large industrial building, and they'll have devices called calorimeters, which can measure the heat and smoke coming off of basically a burning house in some cases. The NIST lab is huge. They can build a small house within their laboratory and set the whole thing on fire and determine what the heat release rates are, and how much smoke is coming off and how much oxygen is being used and things like that. And it's from my point of view, I'm trying to determine how the fire started. So I focus on the small end of it, and I have some furnaces, I have some flashpoint testers, I have some different electrical devices for both putting out varying electrical voltages and currents and measuring them. Because, like I said, my focus is on the beginning of the fire, not the end of it.
I see. Well, awesome. Well, Richard, I can't thank you enough. I appreciate you coming on the show, and you've been a pleasure to talk to. Yeah, thanks again.
Thank you, sir. It's been a pleasure for me as well.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.